NASA has a long record of monitoring Earth's sea surface height. That information is critical not only for tracking how the ocean changes over time, but also for hurricane forecasting. These extreme storms can cost the United States billions of dollars each year, wreaking havoc on lives and property. So meteorologists have worked to improve forecasts for a hurricane's path, or track, as well as its intensity, measured as surface wind speed. The latest in a long line of satellites that monitor sea levels around the globe will help with that effort. Sentinel-6B, the U.S. European satellite launching later this year, will continue the legacy of ocean monitoring to help predict these storms. It is the second of two spacecraft that constitute the Sentinel-6 JASON-CS Continuity of Service mission, a collaboration between NASA-ESA, European Space Agency, EUMETSAT, the European Organization for the Exploitation of Meteorological Satellites, and the U.S. National Oceanic and Atmospheric Administration, NOAA, with its launch planned for no earlier than November 16, 2025. Sentinel-6B will take over from its twin, Sentinel-6 Michael Freilich, which launched in November 2020 as part of a long line of U.S. European missions that have monitored sea levels since 1992. This mission is about continuity, said Karen Amon, Sentinel-6 project manager at NASA's Goddard Space Flight Center in Maryland. We are ensuring that we keep collecting these crucial measurements so scientists can understand how our planet's ocean is changing over time. When it launches atop a SpaceX Falcon 9 rocket from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida, Sentinel-6B will be equipped with two instruments. The first is a radar altimeter that will measure the height of the ocean surface by beaming microwave signals toward the Earth's surface and measuring how long it takes for them to get back. This information will help scientists and forecasters better understand how the ocean is changing over time and in response to climate change, as well as improve forecasts of sea level rise and extreme events such as floods. The second instrument aboard Sentinel-6B is an absolute radiometer that measures the energy emitted by the ocean surface. This data contributes to the accuracy of sea surface temperature measurements used for weather and climate monitoring and will feed into models that simulate ocean circulation patterns and heat transport around the globe. Like its twin Sentinel-6 Michael Freilich, Sentinel-6B will carry a payload data subsystem provided by NOAA. This subsystem receives, processes, and stores data from both of the spacecraft instruments and relays it to Earth via a network of ground stations for distribution to the scientific community. Sentinel-6B represents the continuation of an incredible partnership between NASA, ESA, EUMETSAT, and NOAA, said Chris Chappell, Sentinel-6 mission director at NASA's Goddard Space Flight Center. It ensures the longevity of the JASON series, a remarkable legacy of oceanographic research that began in 1992. The JASON series of ocean monitoring satellites was started in 1992 with the launch of the U.S. TOPEX Poseidon, a joint mission between NASA and the French space agency CNS. After that was the European ERS 1 and 2 radar satellites, followed by the U.S. European JASON 1 and 2, and then Sentinel-3A and 3B. Sentinel-6 represents the continuation of this series. The new Sentinel-6 satellites are named after Michael Freilich, who was the director of NASA's Earth Science Division from 2014 to 2020. He passed away in October 2020, just a few weeks before the launch of Sentinel-6. Aboard Sentinel-6B, components that were not built specifically for the Sentinel-6 mission include the propulsion system, solar array, command and data handling subsystem, and the star tracker, which helps point the spacecraft's instruments at the Earth. These components were provided by ESA, the propulsion system, and solar array were taken from Sentinel-3B when it was retasked for the Sentinel-6 mission. Sentinel-6B will follow Sentinel-6A in a nearly identical orbit, flying over Earth's equator at an altitude of 795 miles, or 1280 kilometers, with a slightly backward tilt of 66 degrees. That means the two satellites will pass over the same track across Earth's surface once every 10 days. While they will operate as one mission, the two spacecraft will fly different paths, because their orbital planes are misaligned by 30 degrees. Together, they will be able to measure nearly the entire ocean surface every 10 days. That coverage is important for accurately monitoring ocean conditions. The Sentinel-6 mission builds on a long history of successful international cooperation, said Felipe Raymond, head of ESA's Earth Observation and ELS Program Office. By making use of existing technologies and infrastructure, we are providing a seamless continuation of JASON's vital service, while reducing costs and time to delivery. Sentinel-6B will keep pace with Sentinel-6A by making small adjustments to its orbit every month or so using small thruster burns. Every 2 years, though, the satellites will need to make larger, more frequent thruster adjustments to account for atmospheric drag. And during these periods, the ground teams supporting the mission will work to ensure the spacecraft remain healthy and continue operating as planned. the Sentinel-6 satellites will continue the legacy of precise sea level measurements that are critical for advancing our understanding of Earth's dynamic ocean, said Paul Delamere, Vice President of Earth and Environmental Sciences at the University of Maryland, Baltimore County, and Principal Investigator of the Constellation Observing System for Meteorology, Ionosphere, and Climate Cosmic. These measurements are essential for improving weather and climate models and for monitoring changes in sea level that result from climate change. The U.S. plays a major role in ensuring continuity of service for the Sentinel-6 mission, which is vital for accurate and reliable sea level measurements. That's why NOAA is providing the payload data subsystem and ground stations for the mission. In addition, the National Centers for Environmental Information, which is part of NOAA, will archive and distribute data collected by the Sentinel-6 satellites. The Sentinel-6 mission exemplifies the type of public-private partnerships that have advanced our nation's weather and climate observing systems, said Neil Jacobs, Assistant Secretary of Commerce for Environmental Observation and Prediction, and NOAA Administrator. We are proud to work with our partners to deliver critical services that protect lives and livelihoods around the world, in addition to its role in improving weather and climate forecasts. The Sentinel-6 mission will also provide valuable data for studying the impacts of climate change on the ocean and coastal areas. For example, the mission will provide data on sea level rise, which is one of the most significant impacts of climate change. By monitoring changes in sea level over time, scientists will be able to better understand how the ocean is responding to rising temperatures and other climate change impacts. The Sentinel-6 mission will also provide data on ocean currents, which play a major role in transporting heat around the globe. As the ocean warms, currents will change, which will impact weather patterns and could lead to more extreme weather events. By monitoring changes in ocean currents, scientists will be able to better understand how the ocean is responding to climate change and what impacts this may have on weather patterns around the world. The Sentinel-6 mission is an excellent example of international cooperation in Earth science, said Mark Lewis, Professor of Physical Oceanography at the University of East Anglia and Chief Scientific Advisor to the UK Met Office. The data collected by the Sentinel-6 satellites will be freely available to the international scientific community, which will allow researchers around the world to study the ocean and better understand the impacts of climate change. Data from the Sentinel-6 mission will also be used to improve ocean models, which are used to forecast weather and climate.